Welcome to RenewEnergy.com, your renewable energy and sustainability platform. At RenewEnergy.com, we believe in the power of clean, sustainable energy to transform the way we live and work. That's why we offer a range of solutions for businesses and homeowners looking to switch to renewable energy sources such as solar, wind, and water. As the global community strives to combat climate change and move towards a sustainable future, harnessing renewable energy sources has become a priority. Wind energy has proven to be a promising solution, especially in offshore areas where winds are stronger and more consistent. The advent of floating offshore wind technology has further expanded the potential for wind energy generation, enabling installations in deeper waters with higher wind potential. This video delves into the workings of floating offshore wind energy, its advantages, and the types of floating platforms that enable this innovation. Floating offshore wind, a game changer. Traditional offshore wind turbines rely on fixed structures, limiting their installation to relatively shallow waters with simple seabed conditions. Floating offshore wind energy overcomes this constraint by using floating platforms anchored to the seabed, allowing turbines to be deployed in larger and deeper offshore areas. This technology offers several benefits. Lower environmental impact. Floating offshore wind platforms can be built and assembled on land, reducing the impact on marine ecosystems and the seabed during installation. Additionally, their location further offshore minimizes visual impact on coastal communities. Ease of manufacture and installation. The assembly of floating turbines and platforms can be completed on land before being towed to the installation site. This process eliminates the need for specialized installation vessels, reducing costs and logistical challenges. Improved energy efficiency. Floating offshore wind turbines can harness stronger winds found in deeper waters, resulting in higher energy output compared to their land-based counterparts or those in shallower offshore areas. Understanding floating offshore wind energy. A floating offshore wind platform, FOWP, serves as the substructure for the wind turbine, providing buoyancy and stability. FOWPs are not founded on the seabed. Instead, they are anchored and moored using flexible anchors, chains, or steel cables. The wind turbines on these platforms convert wind energy into electricity, which is then transported to the shore through underwater cables. There are various types of floating platforms for wind turbines, each with its advantages and challenges. The choice of platform depends on factors such as sea and seabed conditions, wind, turbine size, and available resources. Some common types of floating platforms include barge. Similar in concept to a ship, a barge has a large surface area in contact with water, providing stability. Heave plates are often added to minimize platform movements. Semi-submersible. This design minimizes the surface area exposed to water while maximizing the volume for buoyancy. Vertical cylinders or parallelepipeds are connected by beams and braces to create a surface for turbine installation, with size and distance determining stability. Spar. In a spar platform, most of the weight is placed at the lowest possible point for stability. Long cylinders are required to compensate for the turbine's weight, making this solution challenging to manufacture, transport, and install. Tensioned leg platform, TLP. The TLP is a newer, more technically risky concept that reduces dimensions to lower manufacturing costs. Star-shaped geometry with multiple arms minimizes the platform's volume, allowing it to float without a load. Temporary, reusable floats are used to transport and install the TLP offshore. Floating offshore wind, the future of wind energy. Floating offshore wind technology has the potential to revolutionize the wind energy sector. By enabling installations in areas previously inaccessible due to depth or seabed conditions, this technology contributes to the global effort to transition to renewable energy sources. Research is ongoing to extend the depth range for floating offshore wind installations and improve the efficiency and cost-effectiveness of this technology. As countries across the world continue to prioritize decarbonization, floating offshore wind energy will play a crucial role in meeting renewable energy targets. By harnessing the power of deepwater wind resources, this technology can significantly contribute to reducing greenhouse gas emissions, securing energy independence, and promoting economic growth in coastal regions. To unlock the full potential of floating offshore wind energy, investments in research, development, and large-scale projects are necessary. Challenges and opportunities. Despite the tremendous potential of floating offshore wind energy, there are still challenges that must be addressed to ensure its widespread adoption. High initial costs. Floating offshore wind platforms are currently more expensive than their fixed-bottom counterparts, primarily due to the costs associated with mooring systems and platform construction. However, technological advancements and economies of scale are expected to lower these costs as the sector matures. Grid connection and transmission. As floating offshore wind farms are typically located further from shore, the transmission of electricity to the grid requires longer underwater cables and more advanced technologies. Ensuring grid stability and avoiding energy loss during transmission are critical challenges. Environmental concerns. While floating offshore wind energy has a lower environmental impact compared to fixed bottom installations, potential concerns include noise and vibrations affecting marine life and the release of pollutants during platform construction, operation, and decommissioning. Thorough environmental assessments and mitigation measures are essential. Regulatory and permitting barriers. As a relatively new technology, floating offshore wind energy faces regulatory and permitting challenges in many jurisdictions. Developing clear guidelines and streamlining permitting processes will be crucial to facilitating project development. Collaboration among industry stakeholders, governments, and research institutions is vital to overcoming these challenges and maximizing the benefits of floating offshore wind energy. By sharing knowledge and expertise, fostering innovation, and promoting a supportive regulatory environment, the global community can harness the potential of this game-changing technology. Conclusion. Floating offshore wind energy has emerged as a promising solution in the quest for clean, sustainable, and reliable energy sources. Its ability to harness stronger winds in deeper waters, coupled with lower environmental impacts and ease of installation, make it an attractive option for countries seeking to transition to a renewable energy future. As the technology continues to advance and the costs associated with it decrease, floating offshore wind energy is poised to play a pivotal role in the global fight against climate change and the pursuit of a greener future. Thank you for choosing ReneEnergy.com as your go-to source for all things renewable energy and sustainability. With our YouTube channel, we explore the latest developments and innovations in the field, including hydrogen fuel cells and the use of AI and machine learning to optimize energy consumption. If you're ready to take the next step towards a cleaner, more sustainable future, visit us at ReneEnergy.com and discover the many ways we can help you transition to renewable energy. Thank you for watching and subscribing. Stay up to date on all the latest news and insights by subscribing today.